Good morning, and thank you for joining us in today's Community Care Smart Assistive Technology Collaborative webinar. Before we begin, I would like to acknowledge the traditional owners of the land in which we meet today. We pay our respect to all elders, past, present, and emerging. My name is Georgina Gould, and I am part of the Community Care Smart Assistive Technology Collaborative team and Business Manager at Global Community Resourcing. I'll be moderating today's webinar, which focuses on personalised technologies for people with motor dysfunctions. Before we start today, allow me to go over a few housekeeping points. Our webinar today is being recorded. Questions from today's session have been taken from the Community Care Smart Assistive Technology Collaborative. And if you have any questions after listening to the recording, please email sat@communityresourcing.com.au. Today's webinar is presented by Global Community Resourcing for our online platform, the Community Care Smart Assistive Technology Collaborative. The collaborative is dedicated to advancing the adoption of smart assistive technology in service provision globally with a focus on Australia. Our webinar is tailored to the needs and requests we receive through the collaborative, fostering connections among diverse perspectives in research, development, creation, and deployment of assistive technology in the community care sector. Covering a spectrum of topics in community care, we offer over 70 free webinars that have gathered more than 10,000 views on our YouTube channel. If you haven't already registered on the collaborative site, it is open and free to everyone to join. The platform regularly updates resources, news articles, and collaboration opportunities. Visit www.satcommunity.com.au to become a member and stay engaged with our community. Please note that Global Community Resourcing or the Community Care Smart Assistive Technology Collaborative is not promoting or endorsing any particular products, research agency, or organisation. The purpose of our webinar is to serve and inform viewers of various smart assistive technologies currently in development and/or deployment. In today's webinar, our guest speaker, Associate Professor Sam John, will explore personalised technologies for people with motor dysfunctions. Associate Professor John is the Deputy Head of the Department of Biomedical Engineering at the University of Melbourne. He has a passion for translation of medical technology from the lab to real-world applications. Welcome to the Community Care Smart Assistive Technology Collaborative. Professor, take it away.
Thank you very much for the invite. Thank you for having me come along. It's a great pleasure to talk to you about some of the work that we've been doing. My name is Sam John. I'm an associate professor in the Department of Biomedical Engineering at the University of Melbourne, and I'm the CEO of Assistive Technologies. And we'll talk a little bit about those as well. Like I said, some of my research interests are around neuroprosthesis and brain-computer interfaces. So if you think about electronics and the human body, a lot of the work that we do is integrating the human body with electronics so that we can use that to help us in everyday life. So I was born in India. I grew up, did my bachelor's in Bangalore, and then I moved to Melbourne to do a master's. And while I was doing my master's, one of my lecturers said, "Hey, do you want to do a project with me?" And I went along to have a look. And I was absolutely thrilled by the work that they were doing. And the project that I was working on was called the cochlear implant. Now, some of you may have heard of the cochlear implant. It's a device that's implanted into the ear, and it allows people who have difficulty hearing to be able to hear again. The device was invented here in Australia many years ago, much before I even knew about this. It's now being implanted in kids who are diagnosed with deafness very early in life. And as they grow up, they learn how to use the implant and they're able to hear very clearly in life. The device itself is a very tiny device, as you can see with the coin next to it. And then, but with this device, once it's implanted, it integrates into the body. And what it does is it puts out current pulses into the ear to allow a person to hear. So I was absolutely thrilled by this type of technology and that we could actually interact with the human body and make a difference. So I went on to do a PhD. And my PhD was on the bionic eye. Similar to the cochlear implant, it has some way of seeing an image that's being generated, and then it takes that image, translates that, or changes that into a way that we can communicate with the body. So for example, here, there's a lady who's wearing a pair of glasses, and it's got a camera on it. The camera can take an image of, let's say, a lamp. Then it sends that information to a processing unit at the back, which will change that image into something that we can send to the electrodes that are placed in the eye. And that's sent wirelessly through to the back of the eye. And this here is an image of the back of the eye with the electrodes on it. And using those tiny metal discs or electrodes, we can send a current pulse into the eye and try and make different shapes. So an image of a lamp might be seen as dots that make up an image. And now this particular device is in clinical trials, and hopefully over the next few years, it'll go into translation. And a lot of the work is being done over the last decade or so. But once I finished, I went on to work in another lab where we were looking at something called an endovascular neural interface. What that means is we can take some electrodes similar to what we saw in the cochlear implant or the bionic eye, but instead of putting it directly on the brain or into the eye, we use the blood vessels in the body to put those electrodes to the region we want to go to. So in this example video here, we've got the brain, and then we've got a blood vessel sitting in the middle. We put these electrodes into or very close to the brain. We can record the information that's coming from the brain, and then that sits within a chest pack that's in the body, and that sends that information that we record from the brain to an external computer. And then you can use that to control external computer, you can use that to control a wheelchair, and so on. So that was the project that I was working on for several years after I finished my PhD. And you can use that technology for anything that controls wheelchairs, robotic hands, prosthetic limbs, or a computer to type. There are many companies and many groups around the world who are trying to build technologies like this. The most advanced of them is one of this group here, and they call the BrainGate technology. I'll play a short clip from this video.
In this paper, 2 people with tetraplegia, that is 2 people who are unable to move their arms or their legs in any functionally useful way, were able to control a prosthetic or a robotic arm simply by thinking about the movement of their own paralyzed hand. And they did that using the investigational BrainGate neural interface system. So they thought about using their own arm and hand as though they were reaching out themselves with their own limb, and the robotic arm moved much the way their own arm would have moved. One of the
like you said, in this particular device, what they're doing is the lady has some electrodes implanted into her brain, and you can see this pedestal that's sitting on the top that's connecting to her brain. She's using her thoughts to control this robotic arm to move around. Later in this video, he will show how she can use that to pick up a coffee mug.
Of her own volition. There was a moment of true joy, true happiness. I mean, it was beyond the fact that it was an accomplishment. I think an important advance in the entire field of brain-computer interfaces, that it was really a moment where we helped somebody do something that they had wished to do for many years.
Now, for the first time, she was able to use that robotic hand by thinking about it, and take that jug and drink coffee from it for the first time in 20 years. And that was a pretty amazing accomplishment at that time. But this was actually more than 10 years ago, and technology is still developing. Unfortunately, we're not quite at the stage where it can get to patients to use every day in their life. And so having researched this for nearly 10 years of my life, we were thinking of, is there any way that we can take this technology that's not quite there, but can we use a different type of technology that we can help people now? And so that's where we formed a new not-for-profit company called Assistive Technologies. And the aim is to create custom devices for people living with disability now, using technology that we already know that works to help people. And an example of this was when we were approached by one of the parents of a little boy who's 8. He has cerebral palsy, and he wanted to play video games, and he spent a lot of time watching things on YouTube, but his parents would like him to be able to enjoy and interact with his peers by playing with them, play with his sister as well. And so when he approached us to say, this is what we like to do, we came up with this idea of having a video game controller that he'd be able to use to control a video game at home. And I'll show you another video that shows Jerome playing this video game.
It's making him dizzy. It's only the second time Jerome's had a go at gaming, but it's quickly become a family favourite.
That's a fantastic guy.
The 8-year-old has cerebral palsy, which previously made gaming impossible, even with existing assistive devices. So, students from Melbourne University set out to make a personalised controller uniquely suited to Jerome.
When Jerome touches it, it kind of registers the electrical activity in his skin and then outputs as computer keys. So right now it's programmed to do left and right.
We came up with the kick button so that he could utilize his kick movements to control the game.
The students have spent 8 months working on the prototype, being guided by Jerome's abilities as they adjust and finesse the design.
When he's upset or he's happy, he wants to communicate, he moves his body. So we made a body tracking so that will integrate something that he already does into a system. And none of those things existed before.
The technology developed here for Jerome can be adapted for other children and adults, providing bespoke game controllers for a variety of complex disabilities.
They can use either their brain signals or their eye movements or their muscle movements to control a video game. So again, it has to be very specific to that person.
It's given Jerome a whole new perspective.
I definitely want him to have as much fun as he can. And, he works very hard.
For me personally, it's just having him to be like any other kid, so we can yell at him for playing too much video games.
Something.
Now, you probably can relate a little bit there. So we made this device kind of suited for what Jerome needed to be able to play. And depending on the level of complexity that he was able to use, or the complexity of the movements he was able to use, we've designed the controller to suit him. Now, in a year's time, though, his abilities may have changed. And so he may be able to use something with more dexterous movement. But as that happens, we can adapt the controllers so that it'll be suited for him. And so based on this, we were still developing different types of control systems. Now, in Jerome's case, he was touching the pillow controller that we made for him, but others are able to use their eyes. So in this particular example here, it's a video game that people can play using their eye movements. So we've got a pair of glasses with electrodes on it, which will sense how the eye is moving and then use that to control the software. But we could use the same with anything we want: eye, the brain, the body, muscles, anything that we can use in the body of whatever function there is available. We can use that to control the computer, and through that control either WhatsApp, email, a wheelchair, or a remote controller. And so there's different options that we have, and so we've been working on building this. Now, the operation principle behind this is that whenever we're approached with a need, someone says, this is something that we need built or done, and technology can help in this area. We then go on to a review phase where we'll talk to a few people about it, particularly with the family, with carers, with the allied health professionals involved. Then we'd allocate that to a team, which will then work on designing, building, testing the device. And then we go through a few phases of design, build, and test as we iterate through multiple versions to see, has this version worked? How well has it worked? And then go on to deploying something that, that can be used. Now, the project teams in most cases are made up of the user at the center, the user, but also the user's supporters, their family, allied health professionals, OTs, physios, whoever is helping them on a day-to-day basis, as all of these people are need to know how they can help, how they can help someone keep getting better at whatever it is that they want to achieve. Then we put together a team of project guides, and these project guides are usually people with a disability who may, so let's say someone with spinal cord injury, but they used to work as a software developer before, or they have technical abilities, and they would be able to help with designing this that's suited for the user. And the project guide is also made of other technical experts who are usually people in my team who would work on helping the day-to-day building process. And then we have a team of volunteers who typically students or community members who volunteer to join to do the design, test, iterate phases. And through this path of the project team, we have a clear pathway of taking a need of whatever that need might be and translating that to something that is usable for the person. Now, before I kind of finish, I just want to talk about some of the projects that are coming up with what we're doing. We're planning for the end of this year, having a gaming expo for children with complex cerebral palsy, where we'll have a few of our controllers available. We'll have a few video games, and kids can come in, play a video game, use a different controller, try different things, because not the same controller might not be suitable for every person. So we'll have to work with trying to work out what works best. We're also working on another project, which is a robotic manipulator for people with muscle weakness. So we were approached by another person who's wheelchair bound, can still use their arms, but the weakness has increased so much that it's harder for them to reach and grab items. And so we can make a robotic manipulator that they can still control with the residual function that they do have, but the robotic controller can do all the work, that all the picking up work and the heavy lifting work that's needed. We're also working on a TV remote control, and we were approached by a parent who said, I would love for my adult son to have the ability to control a remote control. Most of the controls that they do have available are not able to be used by them because the buttons are too small, and somebody else has to control the remote for them. And so we're working on making a controller. Now, the timeline for each of these are varied. So most of our efforts are going into creating this gaming expo coming up in December. And then in parallel, we'll be working on the robotic manipulator, and the TV remote control will come a bit later on. So these are just 3 examples of some of the projects we are scheduled to work on this year. But there's a lot more, and the more people send their requests, we start to build a portfolio of which ones we can work on next. So with that, I will thank you all again and finish up there, and happy to take any questions.
Thank you. Thank you, Sam, for your presentation today. We have received a number of questions through the Community Care Smart Assistive Technology Collaborative. So I might just go through a couple of those. Where have your designs resulted in commercialization products?
Yeah, so these particular devices, none of them are commercialized in the sense that we don't sell them. They are they're on a needs basis. So when someone comes to us and says they have a need, we build it specifically for them. We don't get paid for any of these devices. Now, if there is a need where there's more than one person who needs it and there's like hundreds of people, then we would have to separate that out into a commercialization pathway. But at the same time, one of the things that we are really interested in is even if the product is not commercializable in the sense that it's not helpful for thousands of people, but it's helpful for one person, it's still worthwhile making it for that one person. But if it is helpful for more than one, then we spread that particular device out. But if it's not, then we don't move that out of there. So with this gaming controller, for example, we've had several requests for that, but everyone's requests have been slightly different in terms of what they need. So we were looking at making an adaptable one so that you can remove different parts and attach them as you need for any particular person's use. So that's still in the pipeline.
Exciting times to come. Is there any areas that your centre doesn't cover?
So the areas that we don't cover are usually mechanical aids. So things like, I guess, what would we say? Things like exoskeletons, for example. We don't have any exoskeletons, and we wouldn't be making them anytime soon. We don't have mechanical assistive devices, not as many mechanical assistive devices. The main thing is, as long as there's a component of technology involved in it, we can make them. But if it is a, let's say, an adapter for a table that goes on, we don't usually do that. So it's usually, the limitations are, it needs to have a technology and electronics or software element to it.
Great. We have a couple more questions that have come through the collaborative. What are the ethical considerations that arise in the deployment and development of personalized technologies?
That's a great question, and it's actually quite big. And I think one of the let's say, depending on what the users, there is several ethical considerations, and depending on how what the technology is, there's also privacy considerations. So there's even though we might put them all into one bracket, there's multiple different things that we would need to consider. Now, with technologies like this in general, I think the biggest concern is that when people need a technology that they want that might help them, it's making sure that they are the ones who are in control of what that technology is and how helpful it is for them. Now, from our perspective, when we're building this, we're trying to make that as usable for that person, but at the same time, we have to think about what are the safety risks of a particular device. And so having those considerations is something that we take right from the start. So right in that design phase, we list out what are the risks to the person who's using it, but also the person who might be helping that person use it. So all the way through. So, for example, if someone's recording information, their brain signal, it's being sent to a computer, what are the risks involved in the person putting something on someone? What are the concerns with connecting that to a computer? So we do have to consider all of them. And it is very unique to the individual. But if we were to take Jerome's particular thing into consideration, the controller that we made for him, the main concern that we had was because it's physically connecting an electrical circuit to the person, to make sure that the currents that we're going to put in are very low, that when he touches it, there's no way that there's any electrical current that comes back to him. So electrical safety in that instance is the most important. And so depending on the use, there would be other ones that we'd need to consider, but it vary.
It sounds like we could do a webinar just on that topic. And finally, the last question is, how can members of the collaborative get in touch with you and find out more about the conference in December?
Yeah, so we will I'll send out the web email where there's a form, and you can fill out the form and let us know, particularly if there's a need that you feel like there would be a technological way forward that might help. And we'll have a look at that and try and slot that into the pathway. In terms of finding out more, if you put your details through that web form, we'll get in touch with anyone who's reached out, but we'll also be advertising through other forums like the Smart Assistive Collaborative as well. So we'll send that information out by about mid-year this year. But if there's members of the community who have technical abilities, or has a technical background and would like to volunteer their time, we'd love to hear from you as well, because we kind of need everyone who's willing to be involved to come along and be part of the whole process.
Great, thanks, Sam. We'll make sure those details are posted on the collaborative site as well alongside the webinar today. We will be posting today's webinar on the collaborative, so if you haven't already done so, please go online and register. You will also gain access to hundreds of resources, exclusive events and forums on assistive technology and innovation in community care. Please use the link on your screen or head to our website to register to the collaborative. If you have any further questions or inquiries, please contact us at sat@communityresourcing.com.au. Once again, I would like to thank the members of the collaborative research team and today's guest speaker, Associate Professor John. Thank you everyone for attending today's session. We look forward to seeing you again in the near future.